Lesson 6.1, Exponent Properties and E, where we'll learn about simplifying expressions with exponents, simplifying expressions involving E, and rewriting expressions with E as decimals. There are several properties of rational exponents that we've had before. Let's review them. The product property, which says if you multiply with the same base, you add the exponents. Notice the bases are the same, we add the exponents. The power of a product property. So if you have an x you're multiplying and an exponent outside of that group, you can distribute it. Power of power property. If you have exponent, parenthesis exponent, you end up multiplying the exponents. The quotient property. If you divide with the same base, you end up subtracting the exponents. The power of a quotient property. If you're dividing in a group with an exponent on the outside, you can distribute the exponent to both parts of the group. And the negative exponent property, which says if you have a negative exponent, that is reciprocal the base. So x to the negative m is 1 over x to the m. So let's do an example. Simplify the expression. Write your answer using only positive exponents. This example is page 292, number 3. You can see it here. So inside of this group, we're multiplying and dividing. Well, if we use the quotient property and the product property, it says we should be able to distribute this exponent to each part of the group. We can do that when it's multiplied and divided. Should make 3 to the 4, w to the 4, for 2 to the 4, x to the 4. 3 to the 4 is 81. 2 to the 4 is 16. And there we are. Why don't you try page 292, number 1. 6b to the 0. Simplify that. Pause this until you've got it. The answer is 6. Hope you got that one. Alright, something else we're learning about is the number E. I mean, it looks like a letter, but it's actually a number, E. We call it the natural base. It's very, very incredibly useful in calculus because calculus deals with derivatives and integrals, and E as the base makes derivatives and integrals very easy. It's named E because it's named after Leonard Euler, it's pronounced Euler, who discovered it. And it's found by putting really large numbers into this expression, which comes out to be about 2.718. So it's kind of like pi. It's an irrational number like pi. You know, pi is 3.14159, blah, 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 and continues on without stopping. The same thing with E, just that E is a different number. 2.718, 2818, 28459, etc. But it's just a number. So let's simplify some expressions that have E in them. You just treat E like any other letter or number. So for this example, page 305, number 5, we have 5e to the 7x in parentheses with a 4 as an exponent on the outside. So if we use our quotient, or not our quotient, our power of a product property, we can distribute the 4, because we're multiplied here. So I'll have 5 to the 4 and e to the 7x to the 4. Oh, but wait, if I have exponent parenthesis exponent, I can multiply those. So that'd be 28x, 4 times 7. And 5 to the 4 is 625. So it's 625 e to the 28x. Why don't you try number 3 on page 305? Pause this and solve it. Your answer should be 1 over 2e. You can use your calculator to evaluate expressions with e, since e is just a number. So what we're going to do is we're going to rewrite this function to the form of y equals a times b to the x. So I need to figure out what b is. If you notice, all that has the exponent of t on it. All that is b. So I'm going to type that into my calculator to get the decimal. Okay, so I'm going to hit Shift. Most calculators are going to hit Shift. This one just has the E button. And notice it automatically jumps to an exponent. Negative 0.75. Enter. And it says it is 0.472. So that's that b, and then the t is still an exponent. So again, all I did is I just took that part right there, put it in the calculator, and turned it into the base. Why don't you try number 31? The answer is y equals 2 times 1.492 to the t. No, you cannot multiply these because that has the exponent t. The 2 does not, so you cannot combine them because they're not like terms.